This video is the first video for section 5.2 in Honors Algebra 2 at Eden Prairie High School. This lesson is about completing the square. That term has no meaning for you yet, but it comes into play here with quadratic functions. Yesterday we spent a lot of time talking about the three different forms of quadratic functions, and we worked on going back and forth between the three forms. We actually covered just about everything yesterday except how to go from standard form to vertex form, and the way you're going to do that is using a process called completing the square that you are going to learn today. So today's learning objective is to be able to take a quadratic function and change it from standard form to vertex form. To understand completing the square, we're just going to take a couple of minutes on a little investigation here. If you look, you can see I have a square right here. I think of it as the area model for two binomials. So I've got an x plus 1 times an x plus 1, binomial times a binomial. The x times x is x squared, and so on. And the question I'm going to ask for you is how many yellow tiles are needed to complete this square. So to make a square out of this, one yellow tile was needed. So you can see on my chart, we had 2 green tiles, 1 yellow tile. Let's look at this next example. How many yellow tiles are needed to complete the square? Well, here is a full square. And it looks like we had 1, 2, 3, 4, 5, 6 green tiles and needed 1, 2, 3, 4, 5, 6, 7, 8, 9 yellow tiles. Let's look at one more. How many yellow tiles are needed to complete the square? Well, this square, I don't even have all the yellow tiles written here, but let's take a look. For this example, 2, 3, 4, 5, 6, 7, 8, it looks like we had 8 green tiles and we need 1, 2, 3, 4, 5, 16 yellow tiles in order to complete the square. When I think of this one, I see a binomial of an x plus 4 and an x plus 4. So think binomial times a binomial. If you FOIL that out, you get x squared plus 8x plus 16. So one thing that I think is worth noting that we'll talk about later is the b value is how many green tiles you need, and the c value is how many yellow tiles you need. We'll come back to that. Now, have you figured out a pattern? Could you see some sort of pattern? I don't have a picture for everything, but what if I had 12 green tiles, 26 green tiles, 100 green tiles, or n number of green tiles? Could I find a pattern to figure out how many yellow tiles I need? Well, let's see. For this first one to go from green to yellow, well, that did it. I just divided by 2 and I got the number of yellow tiles. What about this one? 6 divided by 2 is 3. That does not get me 9. 8 divided by 2 is 4. That does not get me to 16. 12 divided by 2 is 6. 26 divided by 2 is 13. Well, what could I do now? Is there any way I could get from here to here? 1 to 1, 3 to 9, 4 to 16. And I think in the pattern there definitely is. If I square, 1 squared is 1. 3 squared is 9. 4 squared is 16. So if I had 12 green tiles, how many yellow will I have? Well, 12 divided by 2 is 6, and 6 squared is 36. So I think 12 green tiles will produce 36 yellow tiles to complete the square. How about 26 green tiles divided by 2 is 13. 13 squared is 169. So I'm going to jump down to, if we have n number of green tiles, what will we do to find the yellow? So remember, n then, once we find the pattern, could be replaced with anything, any number. I'm going to divide it by 2. And then we took that number and we squared it. So you could say it's n divided by 2 over 2. Some students like to say n squared over 4. I'm just going to keep it looking like this right here. So it's kind of neat to go back. We had, y equals x squared plus 2x plus 1 was our first square we looked at. The second square we looked at was y equals x squared plus 6x plus 9. The third square we looked at was y equals x squared plus 8x plus 16. And then with the pattern, we'd have y equals x squared plus n divided by 2x plus that n over 2 squared. So I think it's kind of neat to see that the b value was the green rectangles, and the c value, 1, 9, 16, and over 2 squared, was the yellow tiles. That's some patterning to help us set up for going from standard form to vertex form. And I encourage you to look at the next 2 videos to see some examples where I change standard form of quadratic equations to vertex form using the complete the square method. Thank you.